Good morning, students. Today our topic is product of two vectors. So see now, here in this product we are going to see about scalar product or dot product of two vectors and vector product or cross product of two vectors. Okay, first we are going to see the scalar product. So let A vector, B vector be any two non-zero vectors and theta be the included angle of the vectors. Then the scalar product or dot product is denoted by A vector dot D vector. So it's a scalar product means you have to use A vector dot B vector and is defined by modulus of A vector modulus of B vector cos theta. Okay, see modulus of A vector. So A vector is a vector. When you write the modulus, it is a number. So therefore modulus of A vector is a number. In the same way, modulus of B vector is also a number. And what about cos theta? Suppose the angle is 30 degree means cos 30 degree. Cos 30 degree is root 3 by 2. So root 3 by 2 is a number. So modulus of A vector is a number, modulus of B vector is a number, and cos theta is also a number. If you multiply the three numbers, you will get the answer in terms of a number. So it is a scalar, it is a constant. The number is a constant, so therefore the answer, when you take dot product between two vector, your answer is in terms of a scalar. So that's why it is called scalar product. So in between we are using dot, so it is also called dot product. So if you want to write the dot product or scalar product between two vectors, you have to denote A vector dot B vector and is defined by modulus of A vector modulus of B vector into cos theta. Okay, see now, next geometrical meaning of scalar triple product. Here what is the geometrically what's the meaning of the scalar product? So here we have taken two vectors, one is A vector, another one is B vector. So OA vector is A vector and OB vector is B vector. Theta is the angle between A vector and B vector. So from B, you draw the perpendicular BL to the BL to OA. Okay, this OL is nothing but the projection of B vector on A vector. If you place B vector on A vector, that is the projection of B vector on A vector. So which one will represent? This OL represent the projection of B vector on A vector. Okay, so now what we are going to see? We are going to see the meaning of scalar product. Okay, so what is the meaning of scalar product? What is the definition of scalar product? A vector dot B vector is equal to modulus of A vector modulus of B vector cos theta. Now we are going to find cos theta. So for that we are taking a right angle triangle OLB. So in this triangle, here the angle is theta is measured. So so here this one, it's BL is the perpendicular drawn to OA, so this is 90 degree. So this side OB is the hypotenuse. You are going to find cos theta. What's the need to find cos theta? Because in the definition of the scalar product, cos theta is involved. So therefore you are going to find cos theta. Cos theta means what? Adjacent side by hypotenuse. So for this theta, which is your adjacent side? OL. What is your hypotenuse? OB. So that's why we have written cos theta is equal to OL by OB. See now, already we have said cos theta is a number. So therefore OL is also a number and OB is also a number. But here OB vector is given. So vector is there. If you want to write the number, what is OB? OB is the length of the side OB. So that is the length of this line segment is nothing but the magnitude of B vector. So therefore this OB can be written as modulus of OB vector. Okay, so if you cross multiply, modulus of OB vector into cos theta is equal to OL. So modulus of OB vector is what? It is modulus of B vector. Already what we have said about OL? OL is the projection of B vector on A vector. Take the definition of the dot product. So in the place of modulus of B vector into cos theta, for that we can write OL. So therefore this modulus of A vector, it's a number, we can bring it down. So from this you are getting projection of B vector on A vector is nothing but A vector dot B vector divided by modulus of A vector. So the geometrical meaning of scalar triple product is nothing but the magnitude of the first vector, next the projection of B vector on A vector. It's a product of the magnitude of the first vector and the projection of B vector on A vector. From this we can find the formula. Projection of B vector on A vector is equal to A vector dot B vector divided by modulus of A vector. Similarly, we can write projection of A vector on B vector is A dot B divided by modulus of B vector. While writing the projection, so the vector after the word on, that has to be written in the denominator. Here on, after on, which vector comes? A vector. So the A vector should be in the denominator. Here projection of A vector on B vector. After the word on, which vector comes? So B vector. So the B vector is denominator. It is written in the denominator. If you want to write the projection formula, projection of A vector on B vector is equal to A vector dot B vector divided by modulus of B vector. From the geometrical meaning of scalar product, we have found the formula projection of A vector on B vector, that is A vector dot B vector divided by modulus of B vector. So next one, properties of scalar product. So this is the very important result. Using this only you can understand the concept of vector algebra, and it can be used in doing the problems. Okay, so the first one, scalar product of two vector is commutative. That is, the dot product is commutative. What's the meaning? What's the meaning of it? A vector dot B vector is equal to B vector dot A vector. So the scalar product or dot product of two vectors is commutative. Means you can interchange the vectors in the scalar product or dot product. There is no change in it. A dot B, A vector dot B vector is equal to B vector dot A vector. You see that if any two vectors are perpendicular, if two vectors are perpendicular, then the dot product between them is equal to 0. It's a very important result. Okay, two vectors, I have taken A vector and B vector. How is the A vector and B vector? They are perpendicular. A vector and B vector are perpendicular. Okay, use the definition of the dot product. What it is? A vector dot B vector. How it will be written? Modulus of A vector, modulus of B vector into cos theta. Okay, look at this. A vector is perpendicular to B vector means what is the angle between them? The angle is 90 degree. Okay, if you substitute here modulus of A vector, modulus of B vector, cos 90 degree. Your cos 90 degree is what? It is 0. So therefore your A vector dot B vector, it is equal to 0. 0 into anything, it will become 0. So the very important result, if the two vectors are perpendicular, the dot product between them is 0. Why I have written 0 here? Because the dot product of two vectors is a number. So that's why I have written the number as 0. Okay, the next one, A vector dot B vector is greater than 0 for 0 less than or equal to theta less than pi by 2. Pi by 2 means 90 degree. So in 90 degree your dot product is 0. We have discussed in the second point. So here 0 less than or equal to theta less than pi by 2. So therefore your angle is less than 90 degree. So those angles lies in the first quadrant. In the first quadrant your cos theta is positive because magnitude of A vector, magnitude of B vector is positive, and your theta now lies in the first quadrant. In the first quadrant all the trigonometry functions are positive. So here cos theta is involved, so this is also positive. So your scalar triple product is greater than 0 when 0 less than or equal to theta less than pi by 2. And the next one, pi by 2 less than theta less than or equal to pi. Pi by 2 is not included. Pi by 2 less than theta less than or equal to pi. So that means with 90 is not included. So 90 to 180, 180 is included. 90 to 180 means your theta, that is the scalar triple product, is less than 0. Why? Your theta lies in the second quadrant. Pi by 2 less than theta less than or equal to pi means your theta lies in the second quadrant. In the second quadrant your cos theta is, what is it? Negative. These two are positive. Positive into negative is negative. So therefore your scalar triple product is less than 0. Okay, suppose your theta is equal to 0. Angle between them is 0. So how is your A vector and B vector? So both are lying in the same line, same direction. So this is your A vector as well as this is your B vector because the angle between them is 0 degree. So there is no rotation taken place. So therefore A vector as well as this is your B vector. Suppose here I mark OB vector, this is your B vector. So angle between them is 0. Okay. So cos 0, what is that? A vector dot B vector, that is equal to modulus of A vector, modulus of B vector, and cos 0. Cos 0 is what? It is 1. So the answer is modulus of A vector into modulus of B vector. Okay. So when theta is equal to pi, theta is equal to pi, you see that this is your A vector. Okay. Now the angle is 180 degree. So this is your B vector. Okay. This is your B vector. So the angle between them is 180 degree. The angle between them is 180 degree. Okay. So therefore, what is A vector dot B vector? That is modulus of A vector, modulus of B vector, and cos pi. What is cos pi? It is minus 1. So minus modulus of A vector and modulus of B vector. So theta lies in the first quadrant means your scalar triple product is positive. If it lies in the second quadrant means that is pi by 2. Pi by 2 is not included. Pi by 2 less than theta less than or equal to pi, it is negative. Okay. So next we are going to discuss in when the scalar triple product is equal to 0. Any one vector is a 0 vector. So that is A vector is a 0 vector means whose modulus is 0. Modulus எழுதும்போது it will be a number. So that's why modulus of A vector is equal to 0, which implies this A vector is a 0 vector. Or modulus of B vector is equal to 0. That means B vector is a 0 vector. Or the angle between them is 90 degree. In 3 possibilities, the scalar triple product will become 0. So any one of the vector is a 0 vector, the scalar triple product is 0. And the angle between them is 90 degree, or the two vectors are perpendicular, the scalar triple product is equal to 0. So the fifth one, this result is very important. It's another way of representing the scalar product of two vectors. You see here we have taken equal vectors. A vector dot A vector. You see now A vector dot A vector. What is A vector dot B vector definition? Scalar product definition is modulus of A vector, modulus of B vector, and cos theta. So here the same vector is used, not two vectors, the same vector is used. The in the scalar triple product. So modulus of A vector. In B also you are having the same vector, modulus of A vector. And what is the angle between the same vector? Only one vector means the angle is 0. So cos 0. What is cos 0? Cos 0 is 1. So therefore it is modulus of A vector the whole squared. So modulus means it's a number. Modulus of A vector is a number. So that number I will represent as A. So it is A squared. Okay, and you see that A vector dot A vector can be written as A vector the whole squared. So therefore A vector dot A vector is nothing but modulus of A vector the whole squared, that is equal to A vector the whole squared, that is equal to A squared. So the scalar product of equal vectors is a number, that is A squared, or you can write modulus of A vector the whole squared, or this can be written as A vector the whole squared. Now next one, what is I dot I? So what is I? I vector, J vector, K vector. They are nothing but the unit vectors acting along the direction of x-axis and y-axis and z-axis. Unit vectors means whose magnitude is 1. That is modulus of I cap is equal to 1. Okay. So see now, I cap dot I cap, that is j cap dot j cap and k cap dot k cap we are taking. So what is I cap dot I cap? It can be written as, using this, the previous one. What is A vector the whole square? That is A vector dot A vector, that is nothing but modulus of A vector the whole square. So in the same way, I cap dot I cap, that is equal to modulus of I cap the whole square. So I cap, what I have said, it is a unit vector. Unit vector means whose magnitude is 1. So modulus of I cap is 1. So it is 1 squared. So what is 1 squared? It is equal to 1. So that's why I cap dot I cap is equal to 1. Similarly, j cap dot j cap, that also 1. And k cap dot k cap is equal to 1. What is I cap dot j cap? See, I cap dot j cap. So use the definition, modulus of I cap, modulus of j cap, and cos I cap, where it is acting? It is acting along the x-axis. J cap is acting along the y-axis. What's the angle between x-axis and y-axis? That is 90 degree. So cos 90 degree. So cos 90 degree is 0. So therefore I cap dot j cap is equal to 0. So this is the important result for evaluating the scalar product of two vectors in terms of components. That is I dot I is equal to j cap dot j cap is equal to k cap dot k cap is 1. I dot j, that is I cap dot j cap. So if you change it, j cap dot I cap, because it is commutative, so is equal to 0. In the same way, j cap dot k cap or k cap dot j cap is equal to 0. K cap dot I cap or I cap dot k cap is equal to 0. So the next one, if you use lambda and mu scalars, lambda and mu are scalars, we can write lambda A vector dot mu B vector. So the scalars can be taken out and we can take the scalar product of two vectors. So if the scalar is involved in the dot product, so we can take the scalars out and we can take the dot product or scalar product of those two vectors. So it can be written like this using scalar. So next one, for any three vectors, A vector, B vector, C vector, it is left distributive law, that is scalar product is distributive over addition. A dot B plus C can be written as A vector dot B vector plus A vector dot C vector. Right distributive also. A vector plus B vector dot C vector can be written as A vector dot C vector plus B vector dot C vector. So vector identities. So these are will be it is used in the problems. So A vector plus B vector the whole squared. Okay, already we have learned, you see, A vector the whole square. How it will be written? It is A vector dot A vector. Here you are having A vector plus B vector the whole square. How it will be written? See, in the place of A vector you are having now A vector plus B vector. So therefore A vector plus B vector dot A vector plus B vector, isn't it? So you have to take the dot product. So dot product, I have said it is distributive over addition. So take this A vector and multiply with A vector dot A vector plus take the same A vector with B vector, A vector dot B vector plus. So if you multiply these two, B vector dot A vector plus B vector dot B vector. Okay, so what is A vector dot A vector? I have said it is modulus of A vector the whole square plus what is this? It is modulus of B vector the whole square. I already told it is a scalar product is commutative. So B vector dot A vector can be written as A vector dot B vector. So therefore it is 2 into A vector dot B vector. Otherwise modulus of A vector you can write A squared plus B squared plus 2 into A vector dot B vector. In the algebraic formula, not vectors, A plus B the whole square. How will you write? It is A squared plus B squared plus 2AB. It's a number. But while you are using in the vector, it is A squared, or you can write modulus of A vector the whole square. There is no problem. It's a number. A squared plus B squared plus 2 into A vector dot B vector you have to write. You should not write 2AB. It's a number. It's an algebraic formula. But here vector identities, if you want to use A vector plus B vector the whole square, can be written as modulus of A vector the whole square, modulus of B vector the whole square plus 2 into A vector dot B vector. Modulus of A vector is a number. That number we have denoted as A. So that's why it is A squared plus B squared. But while you are writing AB, 2 into A vector dot B vector. Similarly, A vector minus B vector the whole square is modulus of A vector the whole square, that is A squared, plus modulus of B vector the whole square minus 2 into A vector dot B vector. The next one, A vector plus B vector dot A vector minus B vector. You take, what is it? A vector plus B vector dot A vector minus B vector. So how will you write this as? It is scalar product is distributive over addition. So therefore A vector dot A vector. So A vector minus B vector. So the minus 1 is a constant. So you can write minus A vector dot B vector. And take this and you just multiply by here plus B vector dot A vector. Next one, minus B vector dot B vector. Is it clear? B vector dot B vector. So this is nothing but what? Modulus of A vector the whole square. Okay, listen here. This can be written as A vector dot B vector because scalar triple product is commutative. So this is in plus and this is in minus. So both getting cancelled. So here you will have minus modulus of B vector the whole square. So A vector plus B vector dot A vector minus B vector is equal to modulus of A vector the whole square minus modulus of B vector the whole square. So you will have 3 vector identities. And next one. Now, so A vector, B vector is in terms of components, that is x, y, rectangular components, x and y and z components. In this way, if it is written how to find the scalar, what is it? Product. You see, now I'll take what is your A vector. So your A vector now in terms of components we can take it is A1 I cap plus A2 j cap plus A3 k cap, and your B vector can be taken as B1 I cap plus B2 j cap plus B3 k cap. Now you are going to take the scalar product of these two vectors. Okay, A vector dot B vector. Okay, take this first vector and multiply with this. A1 I cap dot B1 I cap. Okay, so see that how it will be written. A1 B1 is a scalar, so you can write A1 B1 I cap dot I cap. Scalar means we can take the scalar out and we can take the scalar product between the vector. So I cap dot I cap, just only we have learned what is I cap dot I cap. It is equal to 1. So therefore you will get A1 B1 and take this vector and multiply with this. Here A1 B2 is a scalar, A1 B2. Now you have to take the scalar product of I cap and J cap. What is I cap dot J cap? It is 0. So we have learned in the 6th property. So I cap dot I cap, J cap dot J cap and K cap dot K cap is equal to 1. So if you change the unit vectors, your answer, the scalar product is 0. So therefore I dot J is 0. Adhe mari the same way I dot K also 0. So take this second component and multiply with this. Here J cap dot I cap, that is 0. You will have J cap dot J cap is 1. So what is that scalar is involved? A2 B2. So plus A2 B2. Okay, and similarly, if you take this A3 K cap, if you multiply with this, these two are 0. Here K cap dot K cap is 1. So therefore you are having A3 B3. So if you want to take the scalar product of two vectors in terms of rectangular components, you have to multiply the coefficient of I cap plus next J cap coefficient has to be multiplied, and the next one K cap coefficient has to be multiplied. Then you have to add all the same components. So that's why scalar product of two vectors is equal to the sum of the product of their corresponding rectangular components. Corresponding rectangular components means I cap here, the coefficient is A1 means it has to be multiplied with the same component of the next vector, that is B1. So A1 B1 plus A2 B2 plus A3 B3. For example, see your A vector is equal to 2 I cap plus 3 J cap plus 4 K cap, and your B vector is equal to I cap minus J cap plus K cap. If you want to multiply, if you want to take the dot product or scalar product of these two vectors, means you have to multiply the coefficient of I component, that is 2 into, here you are having 1, so therefore 2. Next, here you are having plus 3, here you are having minus 1, so 3 into minus 1 is minus 3, and 4 into 1 is plus 4. So the answer is 6 minus 3, that is equal to 3. So scalar product is a number, so you have to multiply the coefficient of I cap and J cap and K cap with the other vectors. Okay, so you have to write the answer in terms of a number, because I dot I cap is 1, J cap dot J cap is 1, K cap dot K cap is 1. So that's why only we have written the coefficients of the same component. Otherwise, the coefficients of I cap has to be multiplied, and the coefficients of J cap has to be multiplied, and the coefficient of K cap has to be multiplied. Then everything has to be added. So the answer is in terms of a number. Okay, so and theta is the angle between the vectors A vector and B vector. So see that what is the definition of A vector dot B vector? It is modulus of A vector modulus of B vector cos theta. If you want to find the angle Cos theta, you keep it in the right side. Bring these two numbers to the denominator. So the answer is a vector dot b vector divided by modulus of a vector modulus of b vector. So if you want to find the angle between two vectors, you have to use the formula cos theta is equal to a vector dot b vector divided by modulus of a vector modulus of b vector. So in the 11th property it is given like this. Okay, so using all the properties we are going to do the problem. Exercise 8.3, the first problem. So find a vector dot b vector when a vector is equal to I cap minus 2j cap plus k cap, and b vector is equal to, what is that, 3I cap minus 4j cap minus 2k cap. You have to take the scalar product. So scalar product, I have written the vector, in between I have written the dot. Okay, so you just now only we have learned the same components has to be multiplied then add. So you take the coefficient of I cap in the first vector, what is 1, here 3, so 1 into 3 is 3. Next, I cap dot I cap is 1, so that's why we have multiplied only the coefficients of the same components. Here the coefficient of j cap is minus 2, here you are having minus 4. If you multiply minus 2 into minus 4, that is plus 8. The same way, take the coefficient of k cap here 1. So in the next vector, what is the coefficient of k cap? That is minus 2. 1 into minus 2 is minus 2. So if you add the number, the answer is 9. In the same way, next one, how to take the scalar product? Take the same, multiply the same coefficients. So therefore here I cap coefficient is 2. Here you are having 6. 6 2s are 12. And next here you are having 2. Here you are having minus 3. If you multiply, that is minus 6. Here you are having the coefficient of k cap is minus 1. In this vector, the k cap coefficient is 2. So minus 1 into 2 is minus 2. So 12 minus 6 is 6. 6 minus 2 is 4. So this is the way you have to find the scalar product of two vectors in terms of rectangular components. Okay, come to the second one. Find the value lambda for which the vectors a vector and b vector are perpendicular. So what is the results are given? A vector and b vector are perpendicular. So what is a vector? A vector is equal to 2I cap plus lambda j cap plus k cap, and b vector is equal to I cap minus 2j cap plus 3k cap. So if two vectors are perpendicular, what the result? Then a vector dot b vector is equal to 0. Here in this problem, given that the two vectors are perpendicular, so therefore a vector is perpendicular to b vector. It is given in the problem. So which implies the dot product between a vector and b vector is equal to 0. So a vector is written, in the middle dot is written, and next b vector is written, it is equal to 0. How to take the dot product between two vectors? You have to multiply the same components. Okay, take the I cap coefficient. Here you are having 2, here you are having 1. So 2 into 1 is 2. Next, j cap coefficient is here in this vector, the first vector lambda, in the second vector minus 2. If you multiply lambda into minus 2 is minus 2 lambda. In the same way, take the coefficient of k cap. In the first vector it is 1. Here the coefficient of the second vector, k cap coefficient is 3. So 1 into 3 is 3. It is equal to 0. Why I have written 0? Because the two vectors are perpendicular. The scalar triple product is equal to 0. So 2 plus 3 is 5. 5 minus 2 lambda is equal to 0. Minus 2 lambda, when you take it to the next side, it is 2 lambda. So 2 lambda is equal to 5. So lambda is equal to 5 by 2. So next one, we are moving to the second subdivision. What is a vector and b vector is given? They are perpendicular, the dot product is equal to 0. So take the dot product. See the coefficient of I cap. Here you are having 2. Here you are having 3. If you multiply the coefficient, 2 3s are 6. Next, you take the coefficient of j cap, that is 4. 4 into minus 2 is minus 8. And here the coefficient is minus 1. Minus 1 into lambda is minus lambda is equal to 0. So 6 minus 8 is minus 2. Minus 2 minus lambda is equal to 0. So when you bring this lambda to the right side, it is plus lambda. So lambda is equal to minus 2. Okay, so come to the third one. If a vector and b vector are two vectors such that modulus of a vector is equal to 10, modulus of b vector is equal to 15, and a dot b is equal to 75 root 2. Find the angle between a vector and b vector. So we have learned how to find the angle between two vectors. Which formula has to be used? Cos theta. So see that cos theta is equal to what? A vector dot b vector by modulus of a vector modulus of b vector. So the formula is written here. Next, what are results are given? Modulus of a vector, modulus of b vector, and a dot b is also given. So in the numerator, in the place of a dot b, you have to substitute 75 root 2. What is modulus of a vector? The formula modulus of a vector is in the denominator, that is 10. And modulus of b vector is 15. So in the denominator, 10 into 15. So 15 and 75 we cancel. So 5 15s are 75. So 5 root 2 divided by 10. 5 and 10 if you cancel, it is root 2 divided by 2. This 2 can be written as root 2 into root 2. So 1 root 2 getting cancelled. You are having 1 by root 2. So 1 by root 2, it is cos 45 degree. So cos pi by 4. So when you equate, your theta is equal to 45 degree. So therefore the angle between a vector and b vector is 45 degree. Come to the fourth question. Find the angle between the vectors. In the previous problem, they have given the results. Modulus of a vector, modulus of b vector, and a vector dot b vector. Here you are having vectors are given. So take first vector as a vector and the second vector as b vector. So what is the formula has to be used? Cos theta is equal to a vector dot b vector by modulus of a vector modulus of b vector. So see the numerator, it is a dot product of these two vectors. Okay, how to find the dot product? The same coefficient has to be multiplied. So here the coefficient of I cap is 2. Here you are having 6. So 6 2s are 12. And next one, here the coefficient of j cap is 3. Here you are having minus 3. If you multiply, minus 9. And here the k cap coefficient is minus 6. Here you are having 2. So minus 6 into 2 is minus 12. Divided by modulus of a vector. So how to find the magnitude of one vector? That is nothing but square root of x squared plus y squared plus z squared. Your x is what? 2. 2 squared is 4. Plus y squared, that is y is 3. So y squared is 9. Plus minus 6 the whole square. Minus 6 the whole square is 36. In the same way, how to find the modulus of b vector? It is nothing but square root of 6 the whole square is 36. Plus, in between you have to write plus, minus 3 the whole square is 9, plus 2 the whole square is 4. So you see the denominator, 36 plus 4 is 40. 40 plus 9 is 49. What is square root of 49? That is 7. Here also the same thing. 36 plus 4 is 40. 40 plus 9 is 49. Square root of 49 is 7. So here this plus 12 and minus 12 getting cancelled. In the numerator you are having minus 9. So cos theta is equal to minus 9 divided by square root of 49 into square root of 49, that is 7 into 7. So minus 9 by 49. So it is angle as asked. So therefore it is cos inverse of minus 9 by 49. So in the second subdivision, you see that these two vectors are given. So first vector is taken as a vector and second vector is b vector. So the formula for finding angle between the two vectors is cos theta is equal to a vector dot b vector divided by modulus of a vector modulus of b vector. So take the dot product of these two vectors. See now here the coefficient of I cap is 1. Here there is no I cap, that means 0. So 1 into 0 is 0. Next, the coefficient of j cap is minus 1. Here the coefficient of j cap is 1. So minus 1 into 1 is minus 1. Next, here there is no k cap coefficient. So therefore it is 0. 0 into here you are having minus 1. 0 into minus 1 is 0. Divided by, how to take the modulus? It's a square root of x squared. X is the coefficient of I cap. So therefore here it is 1. So 1 squared is 1. In between you have to write plus. What is the coefficient of j cap? Minus 1. So minus 1 the whole squared also plus 1. In the same way, if you multiply square root of I cap is not present, so it is 0 squared is 0, and k cap coefficient is 1, so 1 squared is 1, plus minus 1 the whole squared also 1. So minus 1 by root 2 into root 2. What is root 2 into root 2 is 2. So it is negative. So it lies in the second quadrant. So therefore cos of pi minus pi by 3. Okay, it is negative. So it lies in the second quadrant. So it can be written as cos of pi minus pi by 3. If you simplify, it is 3 pi minus 5. That is 2 pi by 3. So cos theta is equal to cos 2 pi by 3 means theta is equal to 2 pi by 3. That is 120 degree. Coming to the problem number 5. If A vector, B vector, C vector are three vectors such that A vector plus 2B vector plus C vector is equal to 0 vector, and modulus of A vector is equal to 3, modulus of B vector is equal to 4, and modulus of C vector is equal to 7. Find the angle between A vector and B vector. So therefore this is the result given. Okay, so here what is asked? Angle between A and B. So A and B result is kept in the left side and bring this C vector to the next side. So it is minus C vector. Already 0 vector is there. 0 vector minus C vector is minus C vector. Then squaring on both the sides. So you will get this result. Now you have to use the vector identities. What is the vector identities? A vector plus B vector the whole square. How it will be written? Modulus of A vector the whole square plus modulus of B vector the whole square plus 2 into A vector dot B vector. The same way, first vector is what? A vector. So modulus of A vector the whole square plus modulus of 2B vector the whole square plus 2 into A vector dot 2B vector is equal to modulus of C vector the whole square. Why we have written? So we know the identity. A vector dot A vector can be written as modulus of A vector the whole squared, or it is A vector the whole squared. Here you are having minus C vector the whole squared. So this can be written as modulus of minus C vector the whole squared. Okay, so modulus of minus C vector is, within the modulus it will become plus. So modulus of C vector the whole squared. So see now, you have to use the identity. Here I have written using the vector identity I have written this. So modulus of A vector here it is given as 3. So it is 3 squared plus, you see now, modulus of 2B vector the whole squared can be written as, it's a number, scalar. So it can be written as 4 into modulus of B vector the whole square plus lambda A vector dot mu B vector. If you have the numbers, you can take the numbers out and you can take the dot product between the vectors. So 2 is a number, 2 2s are 4. 4 into A vector dot B vector. Okay, so here modulus of B vector is what? That is 4. So 4 squared plus, it is angle is asked. So therefore A vector dot B vector definition is used. What is the definition of A vector dot B vector? Modulus of A vector, modulus of B vector cos theta. That means theta is equal to angle between A vector and B vector. That is equal to modulus of C vector is what? 7 squared. So it is 4 squared is 16. 16 into 4 is 64. Here modulus of A vector it is 3. Modulus of B vector it is given as 4. So therefore 964 plus 4 3s are 12. 12 into 4 is 48 cos theta. Bring this 9 to the next side. 49 minus 9 is 40. Bring the 64 also next side. 40 minus 64 is minus 24. Though 48, when it is go to the right side, it will come in the denominator. So cos theta is equal to minus 1 by 2. Okay, already we have seen cos theta is negative, so it lies in the second quadrant, so it can be written as cos of pi minus pi by 3. So it will be cos 2 pi by 3. So therefore theta is equal to 2 pi by 3. So the angle between A vector and B vector is 120 degree. Thank you, students.